we're at the bottom of the hour. Why don't we go to Q&A session first? So let's do that. And again, where's my thing at? Option Y on Mac or Alt Y on Windows. Those are our tools. And actually Ross is in there. He's saying he needs about 10 more minutes to get his machine up and running properly. So
you know, Tim, I do have the Pi Mini. It's set up behind me. If anybody, I mean, it's really not going to show much more than what we saw on the YouTube video. But if anybody who does want to see it, if you're interested, I can certainly show that.
Yeah, fire it up. Okay. Show us.
I'm not sure if the camera is going to be too far away.
Yeah, and then in the meantime, Mark, Mr. Sokol had a question. Mark, go for it, sir. Oh, here, allow participants to unmute themselves. That would be helpful.
Oh, there we go. Hey, how's it going, Brian?
Hey, Mark, how are you?
Not too bad. We haven't spoken in a while. Is there a chance I could get some of the files? We can make some of those parts over here on the CNC machine.
Sure. I can do that. I'm gonna have to unhook my power supply from my laptop so I can get it over here so we can see this a little bit better. But yeah, absolutely.
Also, if you had, if you wanted to try like the Mini or one of your devices inside of an airplane to like do it while it's in a dive to simulate microgravity, I could hook you up with Samuel Mason from the Tesla Science Foundation. He has a couple pilots that would be interested in working on a project like this.
Awesome. That'd be great. That'd be absolutely
like a small Cessna. You could just put it into a dive and just capture video, GoPro cameras, whatever.
Sure.
See what it does in microgravity, you know, during that dive.
Absolutely. Okay, well, we do have the Pi Mini here. I've made some slight changes from the time when it was on the YouTube videos. I took it off of its heavier cart and put it on some smaller sliders. I don't know if anybody remembers, but a while back we talked about the fact that a lot of folks say that it's got to be a stick slip design, and I maintain that it's not a stick slip design, but I guess if you really wanted to call it that, you can, because it requires mass.
Well, now, Brian, let me do this. I want to spotlight you again while you're doing this. And I'm going to set it. Let me see. I'm going to turn off, unmute yourselves. Oops. Sorry. There. I'm going to spotlight that again for you so you can do a good demo. And then, yeah, when you're wrapped up, just, you know, when you're wrapped up, let me know. This will be part of the Q&A session. I don't want anybody to interrupt you though. And my apologies for interrupting.
I appreciate that. Okay, so what we've got is the Pi Mini. It rotates nice and free. It rotates around. We've just got that little weight on it. And I literally just went down to the store and bought the absolute cheapest screw gun that I could find. It was like 10 bucks. I think it was a Harbor Freight store or something like that, China's best. And just made a drive system for it that's so simple that it's ridiculous. But what we talked about there a while back was the need for mass. And this kind of highlights that pretty well. If I leave it on the heavier cart, this is really well balanced. It's very flat. I maintain checking it on a daily basis. I don't even leave to chance that humidity is going to change anything in my workbench top. And with the heavy mass on it, we have movement. It's not fast movement, as you can see. It doesn't move very fast, as you can see, but it does move. But if I get rid of the heavy, this is over 6 pounds all by itself, just that little carriage. This was to really highlight the necessity of having mass. Is this part of it is so lightweight, it rolls really, really easy, regardless of how perfect the pipes are. It rolls very, very, very easily on them. But because the mass is so little, it has a very difficult time going anywhere. Because it only has the one spinning rotating unit, it does tend to twist somewhat side to side. But I mean, this moves so easily that, you know, it's not because it's binding up, it's because of the mass reduction. I don't really have anything more to show with the Pi X, the trammel, but I do have it here. It's on the bench on the other side. I don't know how well the lighting in here is going to allow it to be seen. Maybe that would help. But we do have the new motor on it. It's hooked to a speed controller. I've just simply put that on a fastener on the side of the bench so that it doesn't move around. We've got 48 volts worth of DC batteries underneath the bench to run it on. And we do still have the balance beam on it right now. I can exert maybe a pound and a half of lift, and it'll come off the workbench. Right now, though, I need to readjust the internals in order to get it to demonstrate any actual thrust. I can get it to leap up off the workbench. But right now it needs a massive readjustment before it would actually show any amount of thrust. So there we go. Tim, that's it. That's really and truly all I've got at this time. Hopefully Ross would be able to come on and
yeah, well, let me see. Actually, Harold, let me go to Harold Tavares next. Harold, go for it, sir.
Hey, thank you. You're making good effort in making progress in inertial propulsion. That's good. My question for you is, Thornton tried using, for the brake electromagnet, magnetic field. Have you tried that, and what results have you achieved using magnetic fields?
I've used a magnetic brake, and I've also used a mechanical brake. He actually tried it with a set of brake shoes. Oh, excuse me, automotive brake shoes. They both have about the same effect. They do work. They increase the amount of thrust that you get when the weight is at its full apex of rotation, because it stops any swing out until it's time for that to happen. But they lose more power than it gains for the amount of thrust that they get. That's why I really wanted to find a better way to go about that with the stop, the ramp on the end of the weight, holding it to that center pin a little bit longer. And that way I didn't have to actually try to stop it. It was already stopped. Let's just leave it that way. We won't waste any more energy than we have to by stopping it after it's already trying to leave that center pin.
Have you made some calculation how efficient the machine is?
I really haven't even tried to make calculations of efficiency. I know if you watch the if you watch the videos, Tom Balone was actually in some of those videos, and they did some of the calculations for Roy's original design, which put it at more efficient overall, obviously nowhere near as much power, but more efficient overall than a standard jet engine was in the 1970s, 1980s. Is it still that efficient? I'm certain that it's more efficient than Roy's was, but no, I haven't done any calculations.
Awesome. Okay. Well, oh, you know what? Let me remove spotlight there too. That would help. So who else has questions? It's Option Y on Mac or Alt Y on Windows. And Brian, do you want to try and do some demos too? Or
well, I don't know what else I've got that I can demo for you.
yeah, I mean, I was just thinking back to that collection of videos. You used to have that big collection of videos where you were showing them all, but you know, I just want to get as much exposure for your stuff as possible.
Right. No, I don't have that available to just bring up and show right at the moment. If you go to my YouTube channel, there are a lot of videos there. I mean, I didn't even realize how many there were until I started, saving them to make sure that they didn't disappear if something happened to the channel.
And again, before we pester Ross, and I think he probably needs a few more minutes. Oh, no, Ross said he's ready, but do you want to run us through some of the YouTube videos, or?
Well, we can.
Yeah,
we can
go for it. Go for it. Do screen share again. Yeah, again, I just want to try and canvas as much as possible. We've got lots of time in the Q&A session, so.
Sure. Let me see here. Bring up the YouTube channel.
Yeah, and I have things set so that you guys can unmute yourselves because it is a Q&A session. But yeah, I would say go for it. So I've spotlighted you again, and
okay. And let's see. Back up here a little bit. Is my screen already shared, or do I need to reshare that?
No, you need to reshare. I always turn that off.
Okay. We will share the screen. We'll get rid of this. And we tried a lot of different things as we're going along, and that's why I wanted to make as many videos as I did. They go all the way back to the very beginning, but some of the better stuff, the 4.8 had that the speed controller built into it with the speed changing system, and that was actually a pretty good. Here. All right, working still with the Pi 4.8. Let me fast forward through some of that dry blurbage talking about it. Here we go. On this. So there's the Pi. This is the only one that's doing any work. This is the only one that can swing. In fact, my chain is not even really tight yet. But I wanted to show everyone, as I was getting things set up, the reason the speed differential control was first even thought of is because the machine becomes under load when you really wouldn't think it would become under load. So as the Pi rotates around and this weight is swinging just this way, we have an impact. We come forward. We've got a forward pulse. Then as the Pi rotates around, right here, as the Pi weight is ready to swing out, just before it actually begins its outward swing, the load on the motor becomes dramatically heavier because this is out further, and even though this is swinging free at that point, it's really becoming a much heavier load on the motor. And if it's allowed to slow down at that point, it will actually stop all propulsion. I've already got the speed control set to run small. Show you. It actually does slow down. If you watch the gears right here. It slows every single time. Slows down. Slows down. Slows down. That's all I really wanted to show everybody on this fire as I was getting things set up. I is ready to swing out. Just before it actually begins its upward swing. Okay, that was that one. Let's see. Go back to the channel. Keep hitting the wrong buttons here. Okay, this was one that I thought was pretty interesting. I don't know. Some people said that it still didn't show what I had intended for it to. The stick slip test, where we're talking about whether or not this is running on friction. If it requires friction to keep it from rolling backwards, and that's the only reason that it rolls forward. So I went ahead and I put this on another small carriage, and I put stainless steel slide pieces on there. I made sure that they were absolutely flat and true. And this is what came of that, is that I was able to actually show that it's not sticking in any way to that bottom carriage from friction. So as you can see with that, it was moving the carriage side to side a little bit, but it didn't push the carriage forward with it. It didn't push it backward. Because of the fact that it's only one wheel turning, and it's only turning in one direction. There's some side movement as well as the forward movement. But other than that, that kind of showed pretty well that there's no stick slip going on with that. I've also got some videos from some of the ship-off assemblies, the Tolkien drive, and there's a lot of material there. If anybody really wanted to research how this came to the point where it's at right now, there's more than enough research there to go through. I even videoed some of the stuff that absolutely did not work in any way, shape, or form. 3 planetary gears, bad idea, doesn't work. I tested it, I tried it. As long as there's only one weight on one gear, it works great. put the second weight on the second gear, works a little bit, put the third weight on, and you've wasted your time. Things like that. We've tried it at extremely high speeds. We had lots of pieces and parts flying in all directions. Again, just not what we wanted it to do. So that's really about it there. So let's see. We'll Tim, if you want to shut off my screen share.
Yeah, absolutely. Absolutely. Okay, so I removed Spotlight. Participants can unmute themselves. That was still checked. And I will stop your screen share. There we go. Yeah, and again, anybody, if you have questions, let me see. Yeah, and and folks have kind of put things in there. Say Morgan was saying, I guess these things are like the linear momentum version of the technique that cats use to turn over and land on their feet, dynamic inertia.
Well, there is dynamic inertia going on for sure. And if there wasn't, then we wouldn't see the difference between having the mass in the unit and having lower mass in the unit. But that doesn't mean that it's still not a useful technology and a useful power source for propulsion. If it was only the dynamics of it and absolutely nothing else, then we wouldn't see a difference once it's mounted in a motor vehicle. If anybody wants to think a little bit on this, please be free to and let me know your thoughts, because another thing that we found is that the faster the motor vehicle is moving, the more power the Pi is actually generating. So it's almost exactly the opposite of what you would expect, other than the fact that in relation to space, time, Earth, whatever you want to call it, in relation to that, because the vehicle is moving faster, then the weight is also moving faster, but it's also not stopping the way it normally would if it was simply bolted to a workbench and not allowed to move. So if anybody wants, give any thoughts on that, please feel free to, because it's interesting. It's interesting as we experiment to see all these things happen.
Yeah. So again, I'm going to do one more shout out here, and then we will ask Ross if he wants to present. And actually, so when I do the write up for this, I'm going to get Ross on there. I will create an entire new segment for Ross. And so we'll chase Bryan with Ross. We'll pack them in, which is awesome. So again, Option Y on Mac or Alt Y on Windows. Okay, good deal. Good deal. Everybody's kind of quiet today, but I think, Bryan, I think that's because you presented twice in the past. So
well, and I try to present with all the facts. I don't leave anything to the imagination if I can help it.
Yeah. Yeah.
There's too many people out there that have left so much to the imagination that we're left wondering if they're real, if they're not real, what's really going on. What's not going on. I didn't want to do that. I wanted to make sure that this was open source. If anybody wanted to duplicate, if anybody wants to expand on, if anybody wants to build it better, please do.
Yeah. Yeah. No, you do present really concisely. Yeah. You're definitely not, when you mention that, you're definitely not talking about the Searle effect. I don't want anyone to think that he's talking about the Searle effect. So
no.
Yeah. I'm just messing with you. Okay, so thank you again, Bryan. So let's do this. I want to put this back on gallery view. Everybody, another round of applause for Bryan. Thank you, sir.
Welcome.
Okay, and so